Hey everybody, Mr. Piercy here, and what we're going to be looking at today are going to be properties of angle bisectors inside of a triangle. So there's two particular things that we're going to be looking at. As one is going to be, well, if we have the three angle bisectors in a triangle constructed, do they have a point of concurrency? And if they do, what are its characteristics? What's unique about it? And similarly to what we would have seen with a perpendicular bisector, are there any unique characteristics about the length of a segment or the length of a point from an angle bisector somewhere on the angle bisector itself? So if you're following along trying to do these constructions yourself, you'll need a pencil, your compass, and your straight edge. And I'm just starting off here with a triangle that I called ABC. I made this one acute on purpose. And what I'm going to do is with my compass is first start by constructing the angle bisectors of this triangle. So I'm going to try to keep the constructions a little clean. Okay, so there is, whoops. So here we can line this up, and here is the angle bisector from point C. I'm going to turn my paper here. It's just easier to do it this way because I'm right-handed. So as you're going, and I like doing this stuff because it is good practice with what we've done with constructions in the past. Considering geometry is really the only place that you see a lot of this stuff, I think it's good to use it while we can. So here's the angle bisector from point B. And finally, let's do the angle bisector from A. So when we line our points up, and it looks like I'm off on my construction a little bit, because what we're trying to see, and it's a little off here in the where the three lines intersect, but this should be creating a point of concurrency called, and I'm going to label that point I, because that is going to be known as the incenter. So what's unique about the incenter is if we open up our compass to where it's pretty much perpendicular to the side of the triangle, you should see that it will be about the same distance. And we can create what would be called an inscribed circle. So even though I was off just a little bit on my incenter, you can this is just slightly outside of the triangle here. This is a pretty good representation of what you should be seeing. So from any point, or from the three angle bisectors, they should have a point of concurrency, which in this case is called an incenter. And it's called an incenter because it's the center of an inscribed circle of a triangle. Now, one other thing that I want to point out here real quick while we're looking at this figure, let's just look at the angle bisector from point B. Okay. Now I'm going to give myself points here. I'm going to call this point here X, and I'm going to call this point here Y, where I made my constructions. Now what I'm going to do is I'm going to just pick some points. So let's call that point 1, let's call that point 2, and let's call that point 3. I'm just giving myself a few points along the angle bisector. Now from point Y, I'm going to measure to point 1 from point Y. And then I'm going to repeat the process from X. And we can see that point 1 is the same distance away from X and Y. Well, what about here? let's look at point 2. So using my compass again as a measuring tool, I can see, well, there's that distance, and if I measure it from point X, we get the same distance. What I'm illustrating here, and here we can, if we wanted to, we could measure to the incenter here, and here it's the same distance, or measuring to point, and my hands is awkward trying to measure it that way. Hopefully you can still see okay. From point Y to point 3, come on compass, we can see that they're the same distance away. So with a perpendicular bisector, I would have used point X and Y as the end point of a segment. Well, since we don't have endpoints on an angle, I mean, I could think of maybe point A and point C as the endpoints of the ray that make up the angle. I'm just using these construction marks because I know that they were made from the same distance from point B. So these are fixed points along angle B, along the sides. So anywhere I have those fixed points, anything along the angle bisector itself will be the same distance away from X and Y at the same time. Now the other thing that is interesting is because we have a circle inscribed inside of the triangle, we would be able to draw a radius from the incenter to each side of the circle, something that would be forming a right angle. And those three segments would be the same length because they would have to make up the radius of the same inscribed circle. So those are the two primary characteristics about angle bisectors and the incenter. So first of all, the three angle bisectors create a point of concurrency known as the incenter, as the center of an inscribed circle. And if I know some fixed points along the sides of the angle, we can determine that any point along the angle bisector has to be congruent to the 2 points. Now, real quick before we finish up this lesson, I did this construction specifically with an acute angle. Now, in the perpendicular bisectors video that I did before, I did it with a right triangle as well. Now, here you can see the incenter of the triangle is right here, and the circle inscribed inside the circle that we have. And I also did it with an obtuse angle. And here's my construction for the obtuse angle. Now this one I messed up a little bit here. You can see I missed my incenter a little bit. I had to erase, and I'm off just a little bit here and here. But the reason why I wanted to make sure that you saw the right angle, or the right triangle and the obtuse triangle, is to illustrate that the point of concurrency for the angle bisectors, the incenter, must always be inside of the triangle. Not all of our points of concurrency will be inside of the triangle, but this is one of them that will be. So that is going to pretty much wrap up what I wanted to illustrate about properties of the angle bisectors, meaning that any point along the angle bisector will be the same distance away from a fixed point on the angle, and the angle bisectors create an incenter, which is the center of an inscribed circle. So we'll be going into further detail about how we're going to be using these in our lesson, just talking about how we actually use this. But again, I think it's important that we show you, well, where do these characters come from in the first place? Well, and that's what the constructions allow us to see. We can see, oh, well, it works that way all the time for every triangle. It doesn't matter whether it's acute, right, or obtuse. These properties exist in every triangle that we see. So anyway, I think it's important to see that. But if you have any questions about anything, of course, I'll make sure that you send me a